Welcome guys, welcome my dears, welcome everyone. Here another part of the exponential and the work on the exponential. How we can get the exponential as well to solve the equations using the exponential. I will do this here and I will do it back on the board. Solve 2x squared 2 power 2x plus 2 power x minus 6 will equal 0, like what you see here in front of you. That I will just suppose that I will remove x squared and put instead of it the k instead of x squared. So I will just do like this. It's so big like this now. So I will just move this x squared and put instead of it k. So it will be k squared plus k, because 2x equal k. We said k equal 2x, 2 power x. So here k squared, because this is 2x all square. So it will be k squared plus k minus 6 will equal 0. Okay, I will decompose this, I will factor this. So the two numbers, when I multiply them, they give me 6. And the gap between them is 1. Of course, it's 3 and 2. So one bracket will be k plus 3, and the other bracket will be k minus 2. So I would say this one equals 0 or this one equals 0. Because 0 by this will give me 0, or 0 by this will give me 0. So any one of them will equal 0, and the other one will be whatever it is. But one of them will be 0. So if k plus 3 equals 0, then we can say k will equal minus 3. Okay? Here, if k minus 2 equals 0, then k will equal 2. So if I say here k minus 3, that means 2x equal minus 3, which is logarithm of 0 minus, because here minus, if I take the logarithm for both, I will say logarithm for x, or x will equal logarithm 2 minus 3, which is not solution, because there is no minus 3 in the log. So I have to take the other option when k minus 2 equals 0, which means that k will equal 2. So here I can say that x will equal 1. The idea is using the factor to factor this example and then go through it. Now we will go to the last unit, or one of my favorite units, average rate of changes. Average rate of change. The average rate of change. What is the average rate of change, and what is the meaning of the average rate of change? Usually, we don't have anything constant. We have things that any events is moving, like, and when something is moving, something with it another moving. As example, like the price and the quantity. When the price change, the quantity change. Like as example, the people's birth, the birth rates, the death rates, all these two things are changing upon the time. Here the same thing. So I have facts here, like as example, x is ranging between 2 and 4. So here, let us see the example is saying what? Calculate the average rate of change for the function gx will equals 4x squared minus 5x plus 1 over each interval. So I have here now two intervals, actually. I have two intervals here. So once I calculate it, g for 4, and the other I will calculate it, g for 2. Why? Because it ranges from 4 into 2. Okay, guys, g4 minus g2 divided by 4 minus 2. Okay, my dears. So here, the g4, I will multiply x equal 4. So 4 square will be 16 times 4 minus 5 by 4 plus 1. See this, how much it will be. Then another example, I will do the same when g equals 2. So when g equals 2, let me say 4 times 4, this is 16, minus 5 Multiply by 2, this is 10. 16 minus 10, that's 6 plus 1 is 7. Here it is. The 7 is here. Divided by 4 minus 2. So that will give me 90. Second example will give me 15. The third example will give me 30. When I do this, I'm just doing these examples right now in front of you. Then I will go and work on it on the board immediately. Before the end of this video, I will just add it to this video. We have here an emergency. This is the second example. An emergency flare is shot onto the air. The highest in meters above the ground at the various times its flight is given in this following: the time and the height. So here I have time 0 after 5 seconds, or whatever the units in minutes or seconds. Then after 1 minute, after 1.5 minutes, after 2 minutes, after 2.5 minutes, after 3 minutes, and so on. So I want determine the average rate of change in the height of the flare during each interval. So the first interval here is between 1 and 2. So I have here 1, this is 1, and 2 is here. So the numbers between 2 is 42 minus 27 divided by 2 minus 1. So here I will do H2 minus H1 divided by 2 minus 1. So when I substitute in this, I have already 2 is 42. So here is the 42 minus 1 is 27. 1 is 27 divided by the intervals. Intervals are between 2 and 1. So 2 minus 1 will give me 1. So this will give me 15 miles per second. This numbers in seconds. These numbers in seconds. And this is the heights of the mile. So T, time in seconds, and height in miles. Okay, how to do this? The same thing. H4. What is the H4 here? 42. So I will put 42. Minus H3. What is the H3 here? 47. Here is a 47. Divided by 4 minus 3. The intervals. The intervals are where they here. The 4 and the 3. So 4 minus 3, that will give me 1. Then that will equals minus 5 miles per second. This is not going up. This is going down because it's minus. It's minus. I will do all these examples right now on the board in front of you, but just I want you to see it with me first, then we will do it on the board right away. The population of a city has continued to grow since 1950. Perfect. Since 1950. Yes. The population P in thousands, those are 5,000, 10,000, 20,000, 40,000, 80,000, 120,000, 320,000. The population in thousands and the time T. The time is T in years since 1950 are given the table below and in graph. And what I want here, the rate of change. The rate of change is the difference between the amounts and the difference between the times or the years. So I have the first lot here is between the 0 time. Now, 0 time means now. 0 time means right now. So, and between 20 means 20, as example, 20 years in years here. So now and 20 years, the difference. So I would say 20 minus 5 divided by 20 minus 0. Look at this, what will happen? Okay, P20 minus P0, 20 minus 0. Here is we say 20 minus 5, 20 minus 5. Okay, divided by 20 minus 0. Calculate the average rate of change in population for the following interval between 20 and 0. Yes, 20 minus 0, okay, divided by 20 minus 0. Okay, here, the interval between 40 and 20. So here, the 40 minus. So here, let's go for the first one, 20 minus 0 divided. So here, on 20th, there were 20 million. On 20th, there were 20 million. Here is the 20 million, or 20,000. Minus 0. On the zeros, there was how much? 5,000. Divided by the period of time is from 0 from now up to till after 20 years. So 20 minus 0, that will give me the period of time. That will equal 750 person or increase per year. So these people are increasing 750 for each year. That's based on what? based on one from now until after 20 years. Now this will go into between 20 years and 40 years. Between 20 years, and you get the idea. So you will get now the 40 years first minus 20 years. This is the 40. The slot of the 40 are 80,000. So here I will go. The slot of the 40 are 80,000 minus the slot of the 20, because I want it from 40 to 20. So here 20. They are 20,000. Here it is 20,000. Divided by the periods of time, which is years from 40 to 20. From 40 to 20. Then that will equal 3,000 persons every year. So if it is from the years, because this rate of change is changing, it's not the same. It's changing. Okay. How about the graph? What I will do for the graph? 0. Here, the 0 is the population is 5. So it's 0 is population is 5. Let's go for 10. Population is 10. Here is 10. And the population here 10 and 10. 20th and 20th. Here is 20th and 20th. Here 30th and 40. Here the 30. And this is the 40 in the middle exactly here. Here 40 and 80. Here is 40. And you can see the 80 in front of it here. 40 in front of it, 80. 50 and 160. Here is the 50 in between the 40 and 60. And here it is, and goes in front of the 160, 50 and 160. And finally, 60 and 320. Here is the 60. And when you go up like this dot in front of 320. So I graph the main numbers, the main numbers which I have here in the graph, then I link them together with a line like this way. So this is regarding the rate of change, which is the second. Calculate the average rate of change in the profits for the following intervals. We have the same idea here, the same idea, but we have here a function minus this plus this number plus 11, 15, and calculate. So you will say P2 minus P1. Once you will substitute for S with 2, then once you substitute for S with 1, then you will divide, you will subtract them from each other, and you will divide by 2 minus 1, the interval itself. So here it is when we submitted, when we did it, and divided by 1. The idea is very easy as well. That was for this part. We have also something is called instant rate of exchange, from instant rate of exchange. Let us see what's inside it here. I'll just put this down here. And here, consider the graph shown in front of you. State the coordinates of the tangent points. The tangent points, if you can see here, tangent means touching. It should touch this graph will touch the curve, this line will touch the curve in only one point. We call this point tangent. So this point is 5 and 3. How did I know this? Here it is. If I get for a line like this, here it's 5. And here between 2 and 4, so this is 3. So 5 and 3. State the coordinates of the tangent point. State the coordinates of another point on the tangent. The other point, any points on the tangent of another point in the tangent. Okay? On the tangent line. So this is the tangent line here. Any point here, 3 and 7. That's fine. Use, okay, you take 2 points now. Use the points to find the slope. The slope will be the difference in B's minus the difference in A. So the difference in B, this is B, or this is Y. So difference in Y's divided by the difference in X's. So the difference in Y here, 3 minus 7, 3 minus 7, because Y here is 3, and Y here is 7, 3 minus 7, divided by 5 minus 3, divided by 5 minus 3. So that will equal minus 4 divided by 2, which will equal minus 2. So the slope of this curve, the slope of this line here is minus 2. Okay. Same thing here, and I will get the graph as well. The same thing, and I will get the graph. Use a graph of each function to estimate the instantaneous rate of exchange at x equals 2. At x equals 2, see, look at this here. X equal 2. This is the x equal 2 here. By drawing a tangent line and calculating its slope. So if I draw the tangent line, and I will get the slope of it. The curve is 3x squared minus 5x plus 1. Okay, so I have here now, I have already, this is the line, and this is the tangent. Here is a tangent. Here it is. And I will take 2 points here. I took the point of the tangent, which is 2 and 3. And I will take the other point, which is 3 and 10. Then I'll substitute here, change in y, change in x's. So I will say here, that is 3 minus 10 divided by 2 minus 3. Okay? Or you can take it from up to down, 10. This is 10, 3 and 10. So 10 minus 3 divided by 3 minus 2. That will give me 7. So the change in y, the root change in x is 7 in that case. Same idea here as well. In this graph, like you see here in this graph, we are seeing the functions which increasing and which decreasing. And just we are saying which one, based on what you see in front of you. Y will equal 5x, 5 power x. The function which is increasing, 5 power x, is a. Here it is, 5 power x. Okay. So as example, when 5 power, when x is 1, then it will be 5. Y will be 5. When x is 1, here, y will be 5. Here is y, 5. Okay. When x is 0, when x is 0. So 5x 0 will equal 1. Then y will be 1. Here the curve will be. So this is 1. Let's see the second one, b. Y equal 1 divided by 2x. So which one from those are b? We know now that this one is this one. This for a. Let's go for the second one, which is y equal half power x. This is b. You will see that it's descending. It's not ascending, it's descending here. The reason why, because the more the power, the less the value of the fraction. So as example, let's say on the point, let's say we start from a point 1, but take care because this will never be, x will never be less. It's always 0. So if this is 0, if x is 0, if x was 0, that's the point of x then this half power 0 will give me 1. Then y will be 1. Y will be 1. Here is y will be 1. Here. Okay. Then you can say if x is 1, if x is 1, then y, x is 1 here, then y will equal half. Y will equal a half. Here it is, y equal half. X is 1 in the middle, then y will be half. Half power 1 is half. And so on. And you go by this figure. Third, the C1. Y equals 2x. Let's say that x is 0. Let's say that x is 0. 2 power 0 will be 1. So if x is 0, y will be 2. X is 0, y will be 2. Here it is. We are in the figure C. X is 0, y is 2. Here, 0 and 2. Okay. If x is 1, y will equal 2. X is 1. Here x is 1. Y will equal 2. Here it is. And so on. Same thing. If x is 2, then y will be 4. If x is 2, this is figure C. If x is 2, then y is 4. Here it is. X is 2, y is 4. So I graph it. I graph it and see how it looks like. I put the values like 0, 1, 2, and so on. Then I graph it and see how it is ascending or descending and so on. And so on. Ascending or descending. In the fractions, usually it is descending. In the fraction, like this fraction, half power x, it's going down. And also the same thing in D. If you can see here, D 1 divided by 5 power x. So the value of x's are going down, not going up. Like even the values of x, when it's increasing, the value of y is decreasing because it's a fraction. It's a reciprocal. So it's going down like this way. And you can try many points. And when I work in the board now, I will show it to you practically how it looks like. Here we go back. This is a repeated part of the power of the logarithm, which we are done for. And this is the rate of change, which we just explain it right now. Which I explain it right now. So that is one more things just to do it. Actually, some pieces are repeated here, so that's fine. But I will go back into the rates of change and an instance rate of change. We'll see also how to do it. This part is repeated, so it's okay. I will go now to do this work on the board. So I want you just to pay attention to me, and I will do this right now on the board in front of you. Thank you. I see this examples first, then we will do it on the board together. We will do it together on the board. Let's go for it right now. Okay. Let's now go and see the examples here. The first example, and just make to the board to calculate the average rate of a change in the function gx equal. So I will take it right now on the board. So gx will equal what? 4x squared, 4x squared minus 5x minus 5x plus 1 plus 1. This is the main function which we have, and I need in the period between 2 that's less than x and that's less than 4. In that period of time, which is 2 less than x and x is less than 4, or x is between the range of 2 and 4. What I will do here right now is I would say this will be the G4 minus G2 divided by 4 minus 2. So I will say here solution that will equal, this range will equal G4 minus G2 divided by, here it is, G4 minus G2 divided by 4 minus 2. I will stop share and show the idea of it, how I'll do it. Here we go. Okay, guys. So G4, and we'll supply here, I will write it down here in this area. G4. Here we go. So I will say here G4 or G4 like this, whatever you write it, G4 will equal, I will substitute in the function with the value of 4 for x. So that would be 4 here. X square means 4 square minus 5 multiplied by x. X we said x equal 4. I supply now is 4. G4, x will equal 4 plus 1. So this will equal 4 and 4, 16, 16 and 4. That will equal 64 minus 20 plus 1, which will equal 41. 64 minus 20, that will give me 44 plus 1, that will give me 45. Will give me 45. Okay. What about G2? This is G4, right? G2, I will substitute in the same formula. This is my formula. In this formula, I will substitute with G equals 2 here. Then this will equal 4 x squared. So I will put 2 square minus 5 times 2 plus 1 plus 1. Cool, guys. That's fine. Here, this 2 power 2 will give me 4. 4 by 4, that will give me 16 minus 5 multiplied by 2, 10 plus 1. So 16 minus 10, that's 6 plus 1, that will give me 7. Again, this is 4 multiplied by 4 will be 16 minus 5 multiplied by 2, this is 10. 16 minus 10, that is 6 plus 1, that will give me 7. I have now the values of G4 and I have the values of G2. I get the value of G4, this is G4, and I get the value of G2, this is G2. And the range here from 4 to 2 is fine. Then I can substitute in the formula now. So to substitute in the formula, I will say this will equal G4. How much is G4? 45. Minus G2. How much is G2? 7. Divided by 4 minus 2. That will equal 38 divided by 2. So 38 divided by 2 will give me 1 9. Will give me 1 9. Am I clear for everyone? Clear, guys? This is how it works. Let's go for another example here. This is the 19. Same example for the second one, and for the third one, the same example. We'll just change the number so you guys can do the second and the third one. We'll go now into the next application. And here I will just share the screen to show it to you so that you can know what we are talking about, because sometimes it's not clear. So I prefer that we share the screen here so you can see the example, and from there we go. Okay, guys. The example is saying what? Let us enlarge the numbers a little bit so that you can see it. Okay. Here we go. I think now it's clear. The question. An emergency flare. an emergency flare is shot into the air. Its height in meters. So the height, this height in meters. This height in meters. So it's shot and it go up in the air above the ground at various times in it is giving in the following. So the time here in seconds. Time here in S means seconds. And this is right. As example, for 0, right now, its height is 2 meters. After 0.5 seconds, in 0.5 seconds, its height became 1575 meters. After 1 second, its height became 27 meters. After 1.5 seconds, it became 35 meters height and 75 meters, and so on. So this is meaning the rate of change. Means the time is changing and the height also is changing. Both of them are changing at the same time. The rate of change. The time is changing and the height also is changing. Okay. So now we will go to determine the average rate of change in the height of the flare during each interval. So this interval A, I will do interval A and you guys will do interval B. Same thing, but we will change numbers only. So here, when I do the interval here is between 1 and 2. Between 1 and 2. So let me see. I can see now the height of 2 between 1 and 2. Between 1 and 2. T between 1 and 2. No problem. So the height of 2, the height in the point 2 minus, we said the interval between 2 and 1. The height in the point 1 divided by the intervals, which means the T. T here is between, this is from the old example, you don't need it so that you don't confuse yourself, guys. T here is between 1 and 2. So T here is like this, between 1 and between 2. Okay, so T lies between 1 and 2. So my intervals are 2 minus 1. We'll go now to height 2. The height 2, when you come to see height 2 here, I don't need, I think I don't need now the stop the share. I just want you to watch the, yeah. So I'm saying here, it's height 2 minus height 1 divided by 2 minus 1. 2 minus 1 for the interval. 2 minus 1 for the interval. But those are for the height. How far it is height. Okay. Now, if I go to the example again, if I go to the example, I will find that when I come to point 2, the 2 is 42 meters high. So now I will substitute here. H2, this H2 is 42 meters height minus H1, when 1 is 27 meters height. This is given in the example. 27 meters height, like I showed to you, it's in the example. Divided by 2 minus 1. So this will equal, this will be 15 divided by 1, which will equal 15. 15 divided by 1, here it is. 15 divided by 1, that will equal 1.5. 1.5 what? Meter per second. So this means the height of it is 15 meter per second. Here we go. Here we go. So it is 15 because the height is in meters and per second. So it's 15 meters per second. Guys, the second one is the same and the third one is the same. So again, I will say the idea. I will share the screen and say the idea so everything will be clear. I did it in the board, but also I will do because you have to know how did we get it in the board. And also you saw it in the board right now. Even here you can see it also. You can see it in the board here as well. You can see it also on the board here. I think it's, and we can increase it here. This is on the board, so that's fine. Okay, now let's go into another, this 15 per second. Let's go now into, we share the screen. We need to see the example itself. Here it is. Like I told you, and like you saw on the board also, right? Here, 2 minus 1. We have h2 minus h1, the height 2. On the height 2, it was 42. Here is the 42. Okay, guys? On the height, we have the intervals 2 and 1. We only focus on this, 2 and 1 here. So when the interval was h2, height 2, how much it is? 42. Here is the 42. 42 meters height. Minus h1. Here is h1. h1 is how much? 27. Here is the 27. Divided by the interval. The interval is from 1 to 2. So 2 minus 1. Here it is 2 minus 1. Okay? That will equal, when I finish it, 42 minus 27, this is 15 divided by 1. So it will give me 15 meters per second. The same thing for the second idea and the third idea. The same idea exactly. So we'll go to another slide right now with different idea. Here is another example for graphing a function. And here also we will we have here the time in years and we have the population. And we need the interval between also the same example of the one before. The same example of the one before. Same example, nothing different. Same example. So here I will have between 2 and 1. So this is 0 right now. 2 is how much? 42. We said it. This is the example which we had before, guys. Let's go to the second example here. Okay, this is between 2 and 0 right now. I have here, this is the population, the time, and the population. So as example, 0 means right now, the population was 5 million or whatever. Then after that, 5,000 and 1,000. Then after 10 years, it becomes 10,000. After 20 years, it becomes 20,000. After 30, it will become 40, and so on. So I just need the first interval in between 0 and 20. It's the same idea of the previous example. The same idea. I have t in between 0 and 2. T. So 0 here. And this is the t, the time, and this is 2. The same example in everything. So all I will do is just see on P, on the 2, I needed between the average of between 20 and 0. This is 20 and 0, sorry, this is 20. So I will go to 20. On the 20, I will find it 20. 20. So here it will equal 20. On the year 20, it's 20. Minus on the year 0. Minus 0, it was 5. 0 means current, the current year. Divided by, again, here we go. Divided by, again, I will go to the example. The interval is from 20 to 0. The interval is from 20, means after 20 years, to 0 to the current year. So I want to see the change which happened in this 15 years or in this period of time. So 20, that will equal the 20,000 minus the 5,000 divided by 20 minus 0. This 20,000, like we said, then it will equal 20 minus 5, that is 15, divided by 20. That will equal that will equal 0.75 a year for the year. So the increasing in the people with around 75% for a year. 75% for a year. Okay, guys, this is the rate of change will be 75% for a year. You can also do it 20,000 minus 5,000 divided by 20. You can also do it this. So in that case, it will be, if we do it like this, we would not get the ratio, we'll get the numbers. So we can say like this. On the year 20, or after 20 years, it will be the numbers here in front of 20, it was 20,000 minus. On the year 0, it's 5,000. That it will give me in population, in a real number, but the first one I get it in percentage. I get the rate of increasing in percentage divided by the difference between the two slots, which is 20 after minus 0. The 0 means current now. So this will equal, let me just get to see the screen. That will equal 20 minus 5,000, that is 15,000 divided by 20. So this 0 with 0, and this will equal 750 person per year. So this 700 birth per year. So I will have this 700 per year. Means 750 person had been born in each year. Okay, that is another example in the same idea. And I don't see for you. And when you graph it, you will graph, like I said before, just 1 second. Let me just share the screen back. To share the screen back. Here we go. And of course, like when you see here, when you graph it, you are graphing the main this point. Okay, guys, the main this point. So here, this is 10 to 60, and this is still 320. So you can graph it like I showed you. On here, 0 equals 5. So you go 0 like this, you go up 5 here, up 5. Then 10 and 10. Then 10 here, the middle of 10, you will go up till 10. Then 20 and 20. So you will go for 20 here, and this is 20 as well. And so on. Till you reach. So you graph the figure, the graph of the real example, of the real exercise, which is given to you in the slide or in the example. This is another idea, and I like this idea so much about also the rate of change. About the rate of change, it's a good example for the rate of change. So here the function is, like you see here, 30 s square, 30 s square plus 3.5 s plus 3.5 s plus 11.50 plus 11.15. And you want to get what? Just see here, where S is the profit and the dollars is the number of sweatshirts sold. So calculated the range between 1 and 2. Calculate when S is between 1 and 2. The same idea, guys. Same idea. So I will get the P2. It will equal the P2 minus the P1 divided by the range which I have here, 2 minus 1. Okay, my dears. Then I will substitute in the formula here. I will substitute in the formula. So once I will substitute with the P was 2, and once I will substitute with P is 1. So for P is 2, in this equation, if P is 2, let me just stop sharing the screen. Here it is, and make it like this. So once I will substitute in this formula for P is 1 and for P is 2. So in P is 1, that will equal 30 multiplied by 1 all square plus 3.5 multiplied by 1 plus 11.15. So here, when I do it, that will equal 30 will equal 30 multiplied by 1 is 1 plus 3.5 multiplied by 1 plus 11.15. I will do with this with the calculator. I will add them up with the calculator. They will be 14.35. That will be 14.35. Actually, this is the function. Guys, this is minus, sorry. This is minus. This is minus here. So this minus 30 plus 3.5 plus 11.5. That will equal, how much this will equal? Will equal, when we do it with the calculator, this amount will be 14.35. 14, that will equal 14.35. Okay, guys, it's shown up on the screen here. Yes, okay. And now I'll do P2. When I do P2, then I will substitute here with the amount of 2, not 1. So when I do the amount 2, it will be minus 30. Same. But here is 2 whole square plus 3.5 multiplied by 2 plus 11.15, which is this one. So I substitute this time with 2, not 1, like the previous one. So this will equal, when we finish it, 16.95. 16.95. Okay, guys, I got P1 and I got P2 here now. I got already P1 and I got P2. So I will substitute now in the formula. So here it will equal, P2 is 16.95 minus P1 is 14.14.35 with your calculator. Do it with your calculator. Divided by 2 minus 1, which this will equal 2 minus 1, which finally this will equal this amount of the, when you do the calculating, it will equal 12.6. 12.6. But these are the sales. Sales of what? Of the shares. So the rate of exchange here is 12.6 shares. Okay, guys? That is the thing. The other example here in front of you, you will do the same idea. It will be the same idea. We'll go now to our instant changes and how to calculate the instant changes. Last unit here. So let's go to this example directly, and I will just share the screen as it's important to share it. Here we go. Let me share the screen first to show you what is the meaning of instant or instantaneous changes, and see what do we mean by instantaneous changes here, and how we calculate the instant changes, these changes. Here I have the curve is given to me already. A curve is given to me. I have points for X and point for Y. Assume that the point R The points which I have are 3 and 7. This is the first point, and the second point is 5 and 3. And 5 and 3. So these 2 points, like you see here, 3 and 7, and 5 and 3. If we do a graph, let me just draw any simple graph here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, guys. And I'll just stop sharing so that you can see the board. And I will do the same thing here. 1, 2, 3, 4. 1, 2, 3, 4. And here 1, 2, 3, 4, 5, 6. And I will just graph right now this curve, which was in the exercise. The curve which was in the exercise, it goes from the point 6 and to minus 6 like this, and it's going up into 8. So from 6.5, 1, 2, 3, 4, 5, 6, 7, and this is 8, and this is 6, 7, and here is also 1, 2, 3, 4, 5, 6, and 7. It's going like this, the curve. In that way. And I have here the points of touch is 5 and 3. Here, the tangent is 5 and 3, just 5 and 3, and a point 3 and 7. So this is the tangent line, goes like this. This is the tangent line. It touches here in the point 3. It's in the point 5 and 3. This is point 5 and 3. This point is 5. This point is 5 and 3. And this point is 3 and 7. This point is 3 and 7. Okay, guys. And just now, I need the slope. I need the slope. I need to calculate the slope. The slope will equal, I need to get the slope. So the slope will equal I have here, this is x1, this is y1. This is x2 minus this is y2. Then to get the slope, I will do the same like exactly in front of you here. We can take the points of the first point, which is 3 and 5, and the second point. So here I will say y2 minus y1 divided by x2 minus x1. To get my slopes, I will do like this. So here, y2, what's how the amount of y2? 3. This is y2. 3 minus y1. y1 is 7. Divided by x2 is 5 minus x1 is 3. So 3 minus 7, this is minus 4, divided by 5 minus 3, that's 2. So it will equal minus 2. The slope will equal minus 2. Usually I used to say y2 minus y1 divided by x2 minus x1. It will give me the slope of that. The tangent is the point 5 and 3. This is the tangent. And tangent means what? It's touching the curve in this point. That like touching means like this, as example, like this, just touching, but not intersecting. Touching means it's come to touch the curve in one point here. We call this tangent. So I decided the tangent The tangent is this point. This is the tangent. Is this point 5 and 3. Go 5 and go up 3. That's for this example. So don't forget the slope means y2 minus y1 divided by x2 minus x1. That will give me the slope of the curve. And don't forget it, please. Next idea. Same that we had also as one. So it's the same like the one which we have. And the other one, which I decided, like I show it to you, when is the function is increasing and when it is decaying. I will just write this now in notes here. A function is increasing when y equal a real number. Let's say the number is m power x. This is increasing function. So the function here is increasing. But when y equals 1 divided by m power x, in this case, the function is decaying or decreasing. And this is the idea. Because the fraction, when it is more, it is less. Let me tell you something. Let's say this is 1.5. 1.5 power 1 will equal 1.5. 1.5 power 2 will equal quarter, which is less. So when the function is increasing, when the function, like this, here it is. When the function is an integer, a real number, power x, then it is increasing. Then it's an increasing function, like this here. Y equal m x, this is increasing function. But when it is like this, 1 will equal 1 divided by m power x, this is decaying. And I showed you the reason why. Because if it is half power 1, it's half. If it is half power 2, it's quarter, which is less than the half. So the power, when it goes for the fraction, it goes down. For that reason, this is the way this fraction is decaying. And also, let me share the screen to show you, because this is the last part here in this lecture. Before we go to the limits, I just want to show you something about this. This exercise is telling me what? It's telling me check which one is increasing and which one is decreasing. By other meaning, on the correspondence graph. So let's say this one. This one it must be increasing. For that reason, this is A. Yes, because it's increasing like this. You can see it's increasing. The behavior of it went from quarter 2 into quarter 1. Okay. You substitute those numbers and you can get it for A. Y will equal 5x. This is A because it goes up. The idea which I told you, if the integer is a number and it's increasing, then the whole function will be increasing. It will be going up, all the way up. This one, B. We'll check for, see this, B. This is the one of B. This is the right answer. It is decreasing. It started with a big number, then it goes all the way down like this. See, because it's a fraction. I showed you the fraction. I showed you right now. 1 divided by 2 power 1 is 1 divided by 2, it's half. But 1 divided by 2 power 2 is quarter, and so on. So that means it's decreasing. So like B here. Y equals 2x. Y equals 2x. This is C. Here it is. It's increasing. It's also increasing. 2 power 1 is 2. 2 power 2 is 4. 2 power 3 is 8. So it's increasing. So I accept also C like A. Both are increasing. If you graph it, if you assume as example points like 0, 1, 2, 3, 4, and this one, top, this one, D, Y equals 1 divided by 5 power X. What do you think about it? Here is D. And D also is decreasing. Here, D is decreasing. D is decreasing like B. So B and D, because they are fractions, they are fraction, like what you see here, two numbers, numeration and denomination, and it's raised to power. The values are decreasing, and I told you the reason why. So you can know the value, the one which is increasing and the one is not decreasing. Thanks for paying attention. We'll go to the next part. Thank you.